multiply the big numbers and add the little numbers. So n3 plus n2 to give me n5, n2 times 3 to give me the 6. We'll leave this one to the end because it's a combination of the two. Challenge question. Let's go back and look at our few dividing questions. Strangely, a lot of people got the division questions correct, but muddled up in the multiplying, whether it be the negatives or how you work the powers. Okay, so if we look at this, we could expand it all out, but the first thing I notice, students, is that n to the 4 can be cancelled out in both. N to the 4, n to the 4, that can be cancelled out straight away. Now you look at this at the top, 1 times 3 is how that can get broken down. It's a prime number, there's no other options. Now we want to cancel things out, so we're going to go 1 times 8 times, if we just write m to the 4, because it's not going to go anywhere. Now we can only cancel out our 1's, yeah? So really, it is how we left it. It has to stay as 3 over 8 m to the 4. So this step here wasn't really necessary. You could look at it and go, well, there's going to be no common factors top and bottom to cancel, so you just leave it as the answer. Whereas over here, okay, this is going to be, we're going to make this 2 times 3 for the 6, multiplied by u, multiplied by u, multiplied by v, v, and v, over 2 times 5 times v. Because remember, we're trying to find common factors top and bottom. So now we can cancel out the 2's, and we can just cancel out a v on top and bottom. So we're left with 3u squared v squared. 3u squared v squared all over 5. Okay, so we just write what's left after we've cancelled out those common factors of 2 and the v we could cancel out. Let's write 1 times 3 times x. Okay, I'm not going to write out all those here, but we can recognise it as 3 times 4 times x to the 5 times y to the 5. So basically, we cancel out and we subtract the powers. When we multiply, we add the powers. Okay, when we multiply, we add the powers. When we divide, we're basically subtracting the powers, because you can see up here, we said 3 v's, take away 1 v to give me v to the squared, v3, take a v to give me v to the squared. Okay, the u's had to stay because there was no u's to subtract underneath. So back to this, we can see that our 3's are common. So we're going to have 1 left on the top and 4 left down the bottom. Now let's think about our x's. We have x to the 1 up here, so it's going to get cancelled out. You know, if we think about x on the bottom, and then if we think about 5 x's, 3, 4, 5 down the bottom. Okay, it's just a lot of writing out. But if we have an x at the top and 5 x's at the bottom, then naturally that one's going to get cancelled and it's going to marry up with another one. So we're going to have 4 x's left. And again, that's an example of keep the letter and subtract the powers. Okay, because we don't necessarily have to write this out every time, but x on the top, x to the 5 down the bottom really looks like that. Cancel out and we've got our 4 left. Okay, the y to the 5 is going to have to stay because there's no y's to cancel out anyway.